Hi everyone, this lesson is for grade 12AB elective. Today, the lesson of today is limits of functions. Okay, limit of function. In previous year, when we learn about function, most of the time we will find the value of x, find the domain, range, something like that. And they have some situation we couldn't find it. We all sometimes we answer as undefined. So, for example, if you come to see, right now we're gonna find out what the meaning of limits. Okay. So you see this example on the board. If f of x equal to 0.1 x power 4 minus 0.8 x power 3 plus and so on here. Okay. So if I ask you what the mean, what the answer for the domains or the value of x. So remember, correct? We learned last year. So you see, the first band we will answer right away is what? This one help us, right? X minus 4. So that means our x can be any real numbers except x equal to 4. Okay. At the same time, this one will tell us about the asymptote. Asymptote we learn and help us about have the shortcut and draw the graph faster, right? So then we can find out we have two kinds of asymptotes, horizontal and vertical asymptote. Then when we know this denominator x minus 4 tell us about vertical asymptote. So that means our vertical asymptote will equal to 4 and horizontal asymptote in this case doesn't exist. Doesn't have horizontal asymptote. Why? Because x power 1, x power 4 here, we can do the long division. Everybody call me learn, right? The fastest way how to plot graph. Okay. So now if this function, if you plot graph, is like here, gonna have this graph. So you see, if you replace your when you plot graph, when you replace your x, of course. When x equal to 0, you replace that x equal to 0, 0, you will get this one, right? And so on. If this one is x equal to 1 and 2 and 3 and so on here. Okay? And this 5 and 6. So if you replace 1 and 2 at one at a time, when you replace closer and closer to 4, okay, you will have like you start from here when you work from the left hand side limit. Okay, from this one gonna be like a 3.9, replace it there, 3.999, 3.999 something. When you are closer to 4, our limit, okay, will equal to like a 1.9999 something on the left hand side. And second one, if you find out the limit from the right hand side, when you replace the value of x here. When you replace the value of x from the right hand side, when it approach closer and closer to 4, right? Like at this side, it's gonna be 4.01, 4.00001, 4.00001. When you replace that, this value of x gonna be the value of y. You're gonna get this one equal to 2 also. So the limit of function is kind of dynamic problem. You will find out when the function of x, when the x approaches closer to one number. For example, this one approaches closer to 4. You will be able to get the answer for y. Okay, and then see from this one. If from this case, right? For example, that you can see if you use the graphic calculator, you will find out they have one blank dot here, one blank location here in the graphic calculator. But in the textbook, most of the time you will see they're gonna have one. They use this open dot represent. Okay, open dot sometimes we call void also. Okay, or open dot integer. So this one represent when x equal to 4. This one gonna become open dot. That means the limit concept is the limit from the left, the left hand limit and right hand limit when approach closer both sides to x approach to 4, you will get the value of y equal to 2. That means when you read the limit values, the answer, you read the value of y. Okay, the real value of y. And you can see, like we learned last year, our asymptote, we have vertical asymptote, that means equal to 4, right? So that means it is open dot. We plot in this way, correct? We plot this first because we know our horizontal, vertical asymptote equal to 4. You're gonna have this one, and you're gonna have the dash line. Remember we learned last year, and then you approximate. You know your graph should be somewhere here or here, right? So that's right now this graph we have this meaning at this point. When open, that means when open dot mean that means asymptote position. Okay, that's a x equal to 4. That is about when you learn function. And now say if you want to form this function, right? From this function, if you take limit for both sides, say limit of this function when x equal to 4 equal to 0.1 x4 over 4 0.8 over 3 over x minus 4. This one should write down, take limit for both sides. This one gonna be limit also x equal to 4. Okay, we're gonna take limit for both sides. Then you can form the graph. You can see when approach from the left and from the right, they will make at this point this is y equal to 2. So your final answer limit of this function equal to 2. Okay, everyone following? Understand not? Maybe in this case, let me ask you. Right now, I give you in this example is talk about the existence of limit when the limit does exist. Okay, if I come back to here, according to this graph, when they ask you, say, for example, say if function f of x when x equal to 2, for example, when from this graph, okay, if I say f of x when x equal to 2, what we're gonna answer? Y that means 2, that means you make this point, right? So that means whatever here, this is the answer, right? You write down. Okay. When at the same time, when you from this one, you leave for the limit. If you say limit of this one, when x equals to 2, you will answer from the left, right? You will see this graph happen, this 2 right here, this from the left, and this graph is the right hand side. So you read this graph, lead up to this one, then make 2 here. So when x equal to 2, that's the answer on this one. So you answer y, whatever here. Okay, so that is the concept of limit. But then if I ask you for still on this graph, if I ask you say f of x when x equal to 4, that means x equal to 4. This one you will answer what? Because this is an open dot or the empty dot or y. So with f of x when x equal to 4, the answer is doesn't exist. No answer because it's open. Okay, doesn't exist. But if in this case from this one, if I ask you say limit f of x when x equal to 4, what you're gonna answer? You will answer equal to 2. Okay, in this case you answer to 2. If I ask you function f of x when x equal to 4, this can say undefined, doesn't exist, no answer. Okay, so in this case, if you talk about function before, right, like this one gonna be asymptote line. So when we talk about limit, yes, limit have answer. Okay, from there. Right now, this is the example of limit does exist. Okay, now we go on for next example. Example say, right now, this example I give you two functions. First one, function f of x equal to 0 if x is an integer, And the second function is f of x equal to 1 if x is not an integer. How we plot graph? When f of x equal to 0, when x is integer, what's the integer meaning? Integer numbers have how many kind of integer numbers? Everyone remember we learned last year about the real numbers. Integer have 3 kinds, right? 0, 1, 2, 3, go on until positive infinity, or -1, -2, -3 to -infinity. So when we plot graph for the first one, if f of x equal to 0, if x is integer, so how we plot? If x integer, that means if 0, right? 0 is integer. So your y gonna be 0, correct? So you're gonna have here the back dot. Right now we work on the equation 1, okay? So if x equal to 1, 1 is an integer. So your y gonna be 0. Go on, if 2 is an integer, so your y gonna be here equal to 0. This is 2. And if this one to this left hand side, if x is integer, negative is an integer, right? So your y gonna be at 0, and so on. So when you only the dot on the number line here, this is can say this is equation 1. Now go to the second equation. If f of x equal to 1, if x is not an integer. So if not an integer, say 0 is an integer. So if not an integer, gonna be equal to 1. So you're gonna have the open dot here, right? Because when x equal to 0, this one should be open dot. Because and then next, at the same time, if add 1 here, right? 1 is not 1. Let's say this one is not integer, but 1 is integer. When you plot this one, y gonna be equal to 1, so you're gonna have right here, and so on. If 2 is an integer, but if 2 is an integer, but if not integer, this one have to be open dot, right? And so on here, open dot. At the same time, it's a negative 1. This one is not an integer. That means this one have to be open dot. And this one open dot, and so on. That means for equation 2 here, final graph gonna be this one, right? Connect right here. That means all the position, this is 1. So like this one from 0 to 1, that means this 0 to 1 is this section. This section between 0 to 1. This one can be decimal point, can be fraction, right? So this is an answer for the equation 2 here. So the final graph is this one. Okay, so now this we talk about function, right? Then if I from this graph, if I say I ask you limit of this function x when x equal to any number, for example, if x equal to 2, what the value of this limit of function? Equals to 2, if x equals to 2 is here, right? Now equal to 2. Okay, so in this case, 2 is what equal to? So equal to, because if when limit f of x when x equals to 2, this one you equal to 2 here, right? Because 2 here is only one dot. It happen one dot limit, no answer, doesn't exist. But then it equal to 2 when you go up here, right? From the left here, and from the right, when you equal to 2, there will happen at here. So your limit is going to be equal to 1. Okay. Okay. This the axis of limit, or the when the limit does exist. This is an example. Any question? Non-existent of limits. This one is the axis. Okay. I think we're gonna go the next section.